Imagine you're just, walking down the street and you step off a curb wrong. You twist your ankle.
Yeah, happens to all of us.
Right. So you go home, you rest, you ice it, and eventually the swelling goes down. Fast forward a few weeks, and the ligament is completely healed. I mean, the doctor literally says, you are good to go.
But you still hesitate.
Exactly. The next time you approach a curb, you hesitate. Your heart beats a little faster, you alter your stride, shifting your weight, kind of limping, even though there's zero physical pain.
It's fascinating, right? Because you have to ask yourself why your body is actively protecting a joint that is already structurally sound.
Yeah, and that's exactly what we're unpacking today. Usually we treat an injury purely as a hardware problem, right? Like we rest, we stretch, we try to fix the torn ligament.
But what we're really dealing with here is actually a software virus.
A software virus. The hardware is fixed, but the software in your brain is still running this corrupted, fearful program. So today we are doing a deep dive into some really fascinating 2024 research that explains exactly why this happens and, more importantly, how to clear that virus.
Yes, and we have a fantastic source for this. We're looking at a study published in the Journal of Sports Science and Medicine, authored by Han-Soo Park, Keun, Jun-Young Kim, and Jin-Ho Yoon.
And the title is a bit of a mouthful, but let's hear it.
It is a mouthful. It's called The Effect of Strength and Balance Training on Kinesiophobia, Ankle Instability, Function, and Performance in Elite Adolescent Soccer Players with Functional Ankle Instability, a prospective cluster randomized controlled trial.
Wow. Okay, so it's a rigorous study.
Incredibly rigorous, and it essentially proves that overcoming a physical injury requires literally training the brain not to be afraid of movement.
Right. So to understand how to actually target this software bug, I mean, we first have to look at the vicious cycle of chronic instability and the specific psychological phenomenon that drives it.
The medical community calls it kinesiophobia.
Kinesiophobia, fear of movement.
Exactly. It's defined as an exaggerated fear of movement and the anticipation of, like, a painful injury. And the subjects of this study provide the absolute perfect context for this.
Youth soccer players.
Right, youth soccer players. Because lateral ankle sprains, or LAS, are the most common injury among athletes overall. But in young soccer players specifically, they account for roughly 20% of all injuries.
Wait, 20%? That is a massive chunk of injuries for something that seems so mundane.
It really is. It's a huge portion of athletes losing critical development time. And the common perception is that you just, tape it up and walk it off. It feels highly treatable.
Yeah, the initial injury is treatable. But the problem is these simple sprains often lead to chronic ankle instability, or CAI.
Right.
And then that chronic instability develops into something much more complex called functional ankle instability, or FAI.
And this is where that distinction between the hardware and the software becomes really critical.
Okay, so let's break that down. The mechanical instability is just loose hardware, right? Like the ligaments have physical laxity. They're literally stretched out.
Yes. But functional ankle instability implies the actual communication between the joint and the brain is broken. The brain literally loses track of where the ankle is in space.
Oh, wow. So it's blind.
Basically, yeah.
Yeah.
That loss of tracking is known as a proprioceptive deficit. So your body has this internal GPS system made up of thousands of tiny sensory receptors in your ligaments, tendons, muscles.
Just constantly sending signals.
Exactly, firing signals up the spinal cord to the brain, painting a real-time three-dimensional map of your body's position.
So when a ligament tears,
the physical damage disrupts those sensors, the map gets corrupted. So the joint might be mechanically intact enough to hold your weight after it heals, but the communication network is just heavily compromised. You see neuromuscular and postural control deficits along with muscle weakness.
And this disrupted communication is what triggers that software virus. And to measure this fear, the researchers used the Tampa scale for kinesiophobia, right? The TSK-17.
Yes, the TSK-17. It's a 17-item questionnaire designed to measure this exact fear of movement. The players rate statements from 1 to 4.
Ranging from strong disagreement to strong agreement, right?
Correct.
Yeah.
And a score over 37 indicates a clinical presence of kinesiophobia. The data clearly showed that athletes with functional ankle instability have significantly higher levels of kinesiophobia compared to healthy individuals.
It is wild to think the brain generates fear when the danger has visibly passed. I mean, you would think a structurally sound ankle would automatically signal safe to the brain, allowing the athlete to just get back to sprinting.
You'd think so. But the brain prioritizes survival over peak performance.
Of course.
Right, so the repeated sprains, which these players had all experienced by definition of the study's inclusion criteria, they essentially trained the nervous system to expect trauma.
That evolutionary biology is just fascinating. The brain remembers the acute pain of the initial sprain.
Yes, and because the proprioceptive map is now corrupted, and the brain cannot accurately feel the ankle joint, it just assumes the joint is constantly in danger. To protect you, it proactively alters how you move.
Creating a total self-fulfilling prophecy.
Exactly.
The athlete subconsciously avoids certain movements. They shift their weight or they don't fully flex the joint during a cut on the field.
And that fear-driven avoidance ironically leads to the exact mechanical breakdown they're trying to prevent. Because they aren't using the joint properly, the muscles surrounding it begin to atrophy.
They just weaken from underuse.
Right. Their postural control weakens. This cascading failure makes them far more likely to suffer a re-injury. The fear of the injury causes the very physical conditions that make the injury happen again.
The software virus literally degrades the hardware over time. So if traditional rehab leaves this fear virus intact, how do you actually target it? That is where the researchers did something really clever with these kids.
They pitted two totally different rehab philosophies against each other.
Right, they took 51 elite adolescent male soccer players, aged 13 to 18, from 6 different teams. And all of these kids had functional ankle instability.
They'd all experienced at least 2 previous ankle sprains. They all felt that ghost sensation of the ankle giving way.
And they all scored 25 or lower on the Cumberland Ankle Instability Tool, which is the baseline metric used to confirm the severity of the physical instability.
Yeah, the rigorous setup of this trial gives the findings so much weight. I mean, it was a cluster randomized controlled trial, and it was double-blinded.
So neither the participants nor the researchers analyzing the data knew who was in which group until the end.
Right. They divided these 51 players into 3 equal groups of 17. So you had a strength group, a balance group, and a control group.
And the contrast between what the strength group and the balance group actually did for 6 weeks is just brilliant. Let's talk about the strength group first.
Okay.
Their protocol was all about upgrading the car's engine, giving the joint raw power. So 3 times a week, they sat on the ground and used elastic therabands to work the ankle in 3 specific directions.
Dorsiflexion, which is pulling the toes up toward the shin. Aversion, rolling the foot outward. And inversion, rolling the foot inward.
And they progressively overloaded the joint, right? Moving from a lighter green band to the blue band and finally to the heavy black band.
They also targeted plantar flexion, pointing the toes downward. And the paper notes a really great anatomical detail here. The calf muscles involved in plantar flexion are simply too large and powerful for a simple resistance band to be effective.
Oh, that makes sense.
Right, so to build strength there, the players performed single-leg heel raises over the full range of motion. By week 6, they were grinding through 4 sets of 20 reps.
A pure physical grind to rebuild the hardware.
Yeah.
But then you have the balance group. If the strength group is the engine, the balance group is upgrading the car's navigation and suspension systems. This group didn't touch a single resistance band.
Not one. Instead, they did an 8-minute routine right before their main soccer practice. And the entire progression over the 6 weeks was based on sensory deprivation and engineered instability.
Engineered instability. I love that. And the progression is genius. Week 1, they just performed simple single-leg stances in squats on a solid, predictable floor with their eyes open.
But then by week 2, they remained on the solid floor, but they had to close their eyes.
Taking away the visual.
Exactly. Then in week 3, the researchers introduced a wobble balance board. Because the physical surface was now highly unstable, they allowed the players to open their eyes again to adjust to the new chaotic feedback.
Right.
And finally, for weeks 4 through 6, they escalated to the highest difficulty. The players were standing on the unpredictable balance board with their eyes closed, or they were forced to stand on a single leg while simultaneously having to catch or kick a soccer ball.
They are essentially throwing chaotic stimuli at the brain while asking the ankle to just figure it out on the fly.
Exactly. Meanwhile, the control group just did their normal soccer practices, no extra targeted ankle rehab at all.
Which sets up the ultimate test. If both the strength group and the balance group are actively rehabilitating the ankle, one through raw power, one through neuromuscular control, does simply getting the ankle physically stronger banish the kinesiophobia?
Does a stronger ankle automatically equal a braver brain?
Exactly. And the post-intervention data reveals this fascinating divergence between the body and the mind.
Yeah, if we look at the physical wins first, what the researchers called the secondary outcomes, both interventions were highly successful on a structural level.
Both groups physically improved. I mean, if you want your ankle to perform better on the soccer field, both strength training with bands and balance training on a waterboard will do the trick.
Oh, absolutely. They vastly improved overall ankle stability, measured by that CITE score we mentioned earlier. The researchers also tested the athlete's physical performance using a figure-8 agility test and a lateral side hop test.
And in both of those high-stress dynamic tests, the strength group and the balance group significantly outperformed the control group.
Right. And the strength group, as expected, saw massive gains in raw, isolated ankle strength, particularly in dorsiflexion and inversion, which was measured by a handheld dynamometer.
The hardware was undeniably upgraded in both scenarios.
Undeniably.
But the primary outcome the researchers were looking at wasn't just physical performance, it was psychological recovery. It was that Tampa scale for kinesiophobia.
Yes. And when they looked at the TSK scores after 6 weeks, the strength group improved a little, but the balance group was massively superior at reducing the fear of movement.
The reduction in kinesiophobia had a very large statistical effect size.
Standing on a wobble board for 8 minutes a day cured the fear, while doing heavy, targeted resistance band work didn't quite get there.
That is wild.
Right. And the answer to why that happened lies in the static balance data. So the researchers had the players stand on a high-tech force plate on one leg with their eyes closed for 10 seconds.
Okay, a force plate.
Yeah, it measures the center of pressure. It tracks exactly how much the player sways to stay upright, measuring displacement, velocity, and something called the ellipse area.
So the ellipse area is essentially like drawing a circle on the floor, mapping out their center of gravity. Shrinking that area means they are standing like statues.
Exactly. And the balance group showed massive superior improvements in reducing that ellipse area. They were incredibly still and stable, even when they couldn't see.
And the lack of sight is the key to the entire mechanism, isn't it?
It is the absolute key. When an athlete has functional ankle instability, that internal proprioceptive GPS signal we discussed earlier is incredibly weak. The brain cannot hear the ankle.
Right.
So to compensate for this deaf spot, the brain relies heavily on visual cues to maintain balance. The eyes essentially take over the job of the ankle.
Oh, so when you close your eyes, you rob the brain of its visual anchors.
Exactly. You force the brain to stop relying on the eyes to know where the body is in space. The brain has no choice but to start listening entirely to the proprioceptors inside the ankle joint itself again.
That is incredible. The balance training protocol, especially the weeks with the eyes closed on the wobble board, forced the nervous system to rewire itself.
Yes. It forced the brain to reestablish trust in that internal ankle GPS. By constantly practicing instability, making, thousands of microcorrections a minute on a wobbly surface, they actually rebuilt the brain's trust in the joint's capacity to handle chaos.
Wow. And the strength group was just building muscle. I mean, the muscle was getting thicker and stronger, but the brain was still essentially deaf to the joint's internal signals.
Right. And the researchers mapped this out statistically, and the correlation was undeniable. The data showed an inverse relationship. As the physical stability of the ankle went up, the psychological fear plummeted. So even small improvements in postural control and stability severity can significantly influence and reduce kinesiophobia.
Exactly. Getting stronger is objectively good for performance, but practicing instability and mastering it is what actually rebuilds the brain's trust. That is how you clear the software virus.
You have to prove to the brain in real time that the ankle can survive being off balance without catastrophic failure.
You do. And the implications here extend so far beyond elite adolescent soccer players in South Korea. This fundamentally challenges how anyone who has ever suffered a musculoskeletal injury should approach their recovery.
Totally. The traditional model of rehabilitation, like resting, icing, and then just doing some simple strength exercises, is completely incomplete.
Physical rehabilitation is meaningless without psychological rehabilitation.
It really dictates a necessary shift in clinical practice. I mean, whether you're an elite athlete trying to get back on the pitch or you're just, someone listening who's recovering from a twisted ankle on a weekend hike. Right. Building raw strength won't bring you back to 100% if your brain is still protecting a ghost injury. You have to train your nervous system to feel safe in unstable conditions.
If you skip the balance work, if you skip the proprioceptive training, you are leaving that software bug in the system. And as the study showed, that lingering kinesiophobia will alter your movement patterns, cause muscle atrophy over time, and, ironically, set you up for the exact same injury down the road.
You aren't fully healed until the fear is gone. The hardware and the software have to be upgraded together.
Yeah. We started today by talking about that hesitation at the curb, the fear of a sprain that is already healed.
And if an athlete's physical limitation, their inability to perform at their peak, is actually rooted in a learned psychological fear of movement, it makes you wonder about the general population.
Right. What other lingering physical limitations or pains do you feel in your own body right now that aren't actually physical weakness, but a learned psychological boundary you just haven't trained your brain to unlearn?
Exactly. What if that bad knee or that stiff lower back or that shoulder that never quite feels right isn't actually a hardware problem anymore?
What if it's a software glitch?
Yeah.
It is definitely something for you to think about the next time you find yourself avoiding a specific movement. We strongly encourage you to read the full article by Park, Oh, Kim, and Yoon in the Journal of Sports Science and Medicine to dive deeper into their exact rehabilitation protocols.
Yeah, and the granular statistical findings, too. It is an incredibly practical and accessible piece of academic research. The specifics of their balance progression moving from stable surfaces to unstable ones, with and without visual input, are easily adaptable and highly recommended for anyone dealing with chronic joint instability.
Absolutely. And if you enjoyed unpacking this research with us, be sure to follow the channel and turn on notifications so you never miss a deep dive into the fascinating science of human performance. Until next time, keep challenging those boundaries.